Hi everyone, I'm Wardah, a STEM Scholar Mentor, and today we'll be starting Unit 5 of Algebra 1, Linear Equations. We'll start off with Lesson 1, Modeling Linear Functions. So in Algebra 1, there are a lot of linear equations and also word problems that go with it. So in this lesson, we're going to learn how to evaluate these word problems and how to solve them. So the first step of evaluating a word problem is to read and understand the entire problem. The second step is to underline keywords, focus on variables, operations, and equalities or inequalities. The third step is to convert the keywords into mathematical notations. So we're going to go over mathematical notations in the next slides. Here consider meaningful variable names other than x and y. So if we have, let's just say, cost, they're asking for the cost. Instead of x and y, you could use c, just to make it a lot easier for yourself. For number 4, we write the final expression or equation. And for the last step, we check the final expression or equation for reasonableness. We want to make sure that our equation makes sense. Here are some keywords or mathematical notations that will usually be seen in word problems. So first is sum plus an and this usually correlates with addition. Minus, less, take away, and difference of is with subtraction. Less than is also with subtraction. Product times multiplied by is with multiplication. The fraction of or percent of is also with multiplication. Quotient divided by and ratio of is correlated with division. And is and are usually associated with the equal sign or equals. So these are just some keywords, but here are examples of how it would actually look inside of the equation. The word problem, how it would be worded. So here we have the sum of 5 and x, and that would become x plus 5 or 5 plus x. The next one is 5 minus x. This would become 5 minus x. The difference of x and y becomes x minus 5. 3 less than x becomes x minus 3. The product of 5 times 2 becomes 5 times 2. X multiplied by 4 becomes 4x. 1/2 of x becomes 1/2 x. 33% of y becomes 0.33y. Because we know that in a percentage, in an equation, we never want to leave our percentage in percent form with our variable. We always want to either make it into a fraction or a decimal. And here how we got this decimal is because we know that there's always a decimal point at the end of a whole number. So for percents, we divide this by 100, so it goes 2 decimal places up, and that's how we get 0.33. The quotient of x and y becomes x over y, or x divided by y. The ratio of 2 times y and 4 becomes 2 times y up here divided by 4. The sum of 5 and x is 20 becomes 5 plus x equals 20. Now we're going to go over some questions together. So the first one is, the length of a rectangular window is 5 feet more than its width w. The area of the window is 36 square feet. Write an equation that could be used to find the dimensions of the window. So here, for this question, we can actually just draw it out since they're giving us some shapes. So here's our window, and we know that it's given that we have an area of 36 feet. It's also given that our width is w, and we know that the width of a rectangle is always the shorter side. So here we have w, and the length it says is 5 more than its width. So it's going to be 5 plus w, or w plus 5. Now, so the information that we have so far is that our area is 36, our width is w, and our length is w plus 5. So, and we also know that the area of a rectangle is length times width. So once we input our information from here into our formula, we're going to end up with w plus 5 times w is equal to 36. And if we simplify this down, we get w times w plus 5 equals 36, which is our final equation. Next, we have 3 times the sum of a number and 4 is equal to 5 times the number decreased by 2. If x represents the number, write an equation that is a correct translation of the statement. So this is kind of a wordy problem, but first we're going to start off with our variable. So x is going to represent a number. It says it right here. Now, so here it says is equal to. So we know that this is going to be a two-part equation. It's going to have an equation in the middle. Now, the first part of the equation is 3 times the sum of a number and 4. So, we're going to start off with the sum of a number and 4, which will be x plus 4. Then we're going to add this part to it, so 3 times the sum of a number and 4. So 3 times this, and then we're going to move on to the second part of the equation. 5 times the number, 5 times x, decreased by 2, minus 2. This should be a minus, sorry for the typo. So then our final equation will be 3 times x plus 4 equals 5x minus 2. Now, I want you guys to do some questions on your own, so just pause the screen and complete them. Here are the answers that you should have gotten. Number 1 is 3 and number 2 is 4. So let's go over them. For the first question, it says, Kendall bought X boxes of cookies to bring to a party. Each box contains 12 cookies. She decides to keep 2 boxes for herself. She brings 60 cookies to the party. Which equation can be used to find the number of boxes X Kendall bought? So first, we're going to start off with our variable. X is equal to the number of boxes. And we know that each box contains 12 cookies. So it would be 12 times x, because x is the number of boxes and we don't know how many boxes she has at the moment. So 12x, and now she decides to keep 2 boxes for herself. So this would be minus 2, but since we're going in terms of cookies, we're going to multiply 2 with 12. So we would have minus 12 times 2, 12 for the number of cookies and 2 for the number of boxes that she's keeping for herself. And our last part of the equation is the total number of cookies that she's bringing to the party, which is 60 cookies. So once we simplify this down, we have 12x minus 24 equals 60, which is choice number 3. For the next question, it says a typical cell phone plan has a fixed base fee that includes a certain amount of data and an overage charge for data use beyond the plan. A cell phone plan charges a base fee of $62 and an overcharge of $30 per gigabyte of data that exceeds 2 gigabytes. If C represents the cost and G represents the total number of gigabytes of data, which equation could represent this plan when more than 2 gigabytes are used? So, ignore the 62 here, we'll get to that. But first of all, we're going to get our variables out of the way. So they said that C is the cost and G represents the total number of gigabytes. So we're going to label those. Next, we can get a clue from the answer choices because all of them start with C equals. So we know that our equation has to start with C equals. But the reason why is because 62 and 30, these are all units of money. So we know that our total amount is going to be the cost. So we're going to have C equals. Now we're going to go to our base fee of $62. So what this means is that the $62 have to be here. This is a constant, which means that no matter how many gigabytes a person takes, they'll always have to pay $62. So this will just stay here. Next, we have our overage charge of $30 per gigabyte of data that exceeds 2 gigabytes. We're going to get to the 2 gigabytes part later, but first let's focus on the overage charge of $30 per gigabyte. So since it says per gigabyte, we know that the $30 is going to be multiplied by some sort of variable. In this case, it'll be G. So we're going to add this to our 62. And then for the last step, we have exceeds 2 gigabytes. So we know that because it's exceeding 2 gigabytes, G is going to be subtracted from 2. So it'll be 2 minus G. And this is our final equation, which is choice number, it should be G minus 2. But it should be 4, and let me explain why. because since it exceeds 2 gigabytes, we know that G has to be bigger than 2. So this should be fixed to G minus 2. So this is our final equation, except G and 2 should be switched, which is choice number 4. That's all for this lesson. Thank you for listening, and if you have any questions, don't be afraid to contact my email down below. And if you're looking to practice with any additional resources, JMAP and Khan Academy are some great ones.